Good morning, everybody. My name is John Handler. I'm a Principal Search Specialist SA with Amazon Web Services. And today we're going to talk about our enhanced security in Amazon Elasticsearch Service that we launched just last week. So as we look at what you're trying to accomplish with your security setup, and especially with respect to Elasticsearch, first thing is you want your data to be encrypted. You want to keep that data secure when it's flowing across the internet, or if it's within your VPC, you'd like that to be encrypted. Within the cluster itself, you'd like that to be encrypted. You'd like your data encrypted at rest, and you'd like to be able to set that encryption up. You want to authenticate and provide user identities and differential access for the users that are coming in to use your Elasticsearch cluster. With our new fine-grained access control launch, you're able to provide a granular access for individual users down to a field level within your Elasticsearch cluster. We're going to cover this in a great deal of detail. Very excited to bring this launch out, and we hope that you will use it well. So I know probably many of you are familiar with Elasticsearch and familiar with Amazon Elasticsearch Service, but I thought I'd spend just a few minutes talking to what is Amazon Elasticsearch Service and get to bring in the folks who may not be familiar with it. So Amazon Elasticsearch Service is a fully managed service. It makes it easy to deploy and manage and scale Elasticsearch and Kibana within the AWS cloud. We launched the service about 5 years ago with the idea being that we would make it easier for our customers to run Elasticsearch in the AWS cloud, and we would provide the operational and undifferentiated heavy lifting of running that cluster to let you focus on the core mission for Elasticsearch. For those of you not familiar with Elasticsearch at all, Elasticsearch is a search engine. And a search engine is a technology that allows you to put a number of different documents into it and perform either free text or field-based search, along with a notion of ranking and relevance that provides you with results that are the best answers for particular queries. As Elasticsearch was deployed and came out and people started using it, it developed additional technologies and that supported more of an analytics workload. And especially we see many of our customers flowing their log data into Amazon Elasticsearch Service and then using an open source tool called Kibana to visualize data within that Elasticsearch clusters. This supports workloads like real-time monitoring for your infrastructure, real-time monitoring for the security stance of your applications, application performance. We see a ton of people doing DevOps with Amazon Elasticsearch Service. We also can look at the product or feature performance itself. So whether you're doing search or whether you're doing analytics, Elasticsearch Service can be the tool for you. Elasticsearch itself is a database technology, and it works very much like a database. The first thing is we're going to send our data as JSON via REST APIs to Amazon Elasticsearch Service. And again, we have our two use cases here. We have servers, we have applications, we have networking, AWS. We have tons of technology that's generating log data, and we're going to flow all that data to Elasticsearch for indexing, visualization, analysis, all of that. Second use case is application data. This is things like e-commerce, where I have a product catalog and I'm going to provide search across that catalog. Hopefully people will buy my products. And we're going to flow that data to Elasticsearch. When the data arrives at Elasticsearch, Elasticsearch creates indexes on all of the fields of the data that comes in, including in nested JSON. This provides you the means of searching any piece of data that you have that's associated with the document that you sent in. This is in distinction to other database technologies which don't index everything. Elasticsearch is designed to index everything. And then at the other end, you send queries again via REST APIs. They allow fielded matching, Boolean expressions, sorting, analysis, all kinds of things. We see application users, analysts, DevOps, security folks using either direct APIs or using Kibana to build visualizations. When we use Elasticsearch Service for log analytics, we use Kibana generally, although people do use direct to API for deep level analysis. But we'll use Kibana to connect to Elasticsearch, and we'll create visualizations across the log data that is in the cluster. So this is a snapshot of a Kibana dashboard. It is actually hosting data about an Elasticsearch cluster. You can see we have various kinds of visualizations. We have some histograms, stacked bar charts, we have line graphs, we have some gauges. There's a large selection of visualizations that you can build within Kibana. Our customers use Amazon ES to achieve a number of different goals. Financial Times uses Amazon Elasticsearch Service to flow in web clickstream data, and they're able to expose dashboards that let their journalists see how popular their articles are. Their journalists love this feature. They love to go and see how many people are reading their content. They also use it for the editorial board to make decisions about what they should publish based on trending topics and other things. Expedia uses Amazon Elasticsearch Service in a number of different ways. They have a number of different monitoring workloads across containers as well as AWS infrastructure to be able to see what's going on with their infrastructure in real time. Pearson moved all of their log data into a centralized solution, and they were able to use the fast ingest and fast time to visualize to react to situations that were happening in their production environment. Nike supports their real-time search, their product search, with Amazon Elasticsearch Service. And then we have Autodesk, who centralizes logs, again, across a large organization to be able to do not only individual monitoring, but also a more broad security and other type of monitoring. Lastly, we have Sophos, who uses Amazon Elasticsearch Service to provide security monitoring specifically as an application. So the core concepts that we're dealing with are users, roles, permissions, action groups, backend roles, and role mappings. When we talk about security, what we're talking about here really is authentication and access control over the data that you have within Elasticsearch Service. And a fundamental core concept is the user. The user makes requests to Elasticsearch. They have to authenticate and identify themselves in some way, and we'll talk about a number of different ways that you can apply authentication to indicate which user is sending this request. We have roles. Roles define a scope in terms of the cluster, the indexes in the cluster, for permissions to be applied for particular users. So users will come in, they'll authenticate, and then they will get the roles that are assigned for their particular user, and that's what controls what they're permitted to do, which brings us to permissions. We have individual actions, things like creating an index, reading data from an index, making cluster level commands. Those are the permissions that are grouped together in action groups. An action group is a set of permissions, and in fact, a role gets an action group, and then that role is put on a user. That's how the permissions are propagated to the users. We also have the concept of backend role. A backend role is an identity that's provided by an external system. With Amazon Elasticsearch Service and with our new security launch, the backend roles that we support will be all Cognito-based. And again, we'll get into that in a minute. And then finally, we have role mappings. Role mappings, again, map roles onto particular users. The authentication and access control is multi-layer, and it can get quite complex, so we're going to build it up from the ground up. First, we have our sources of traffic. So we want to discriminate here between traffic that's coming from Kibana and that's going to access the cluster, and traffic that's direct to API. Kibana itself is a thin web client that's generating HTTP requests. They're of a particular form that makes them a little bit different, and the fact that it's an open source product means the authentication is a little bit more difficult. So we have a lot of different possibilities in terms of how we're going to provide authentication and the access that's going to be applied based on that. With Kibana, we support integration with Amazon Cognito. When you first enter Kibana, if you enable Cognito authentication, you'll be passed off to Cognito, which provides a login screen. You'll configure Cognito to apply a role to the authenticated user, and that is the identity that will come to Amazon Elasticsearch Service. The other way that Kibana goes is without authentication, Kibana can attempt to connect. For direct to API, we usually would see using AWS Zigbee for signed requests. Those signed requests would go and would generate essentially as authenticated a particular user or role to be authenticated within the service. And then finally, we have HTTP basic auth, which is just username password that can be passed along with a particular request. When you use Amazon Elasticsearch Service, you can launch within your VPC. And if you do so, you launch within a particular security group. The traffic itself has to be authenticated at that edge, that first edge, not authenticated. The traffic is gated at that initial edge, and your security group can allow or deny traffic depending on the source of the request itself. We have two layers within the service itself, and it's important to discriminate between the edge authentication and then the deeper level authentication. If we look at the pre-launch of our fine-grained access control feature, this is the security model we had to that point. So our edge authentication is backed by IAM. You use IAM policies to specify whether particular entities or particular IP addresses can perform actions within Elasticsearch Service. We have the user or role. If the traffic comes in authenticated with a user or role, then we'll apply the access control of the policies that are either there for the user, or you could write a policy and put it onto the domain itself. If the traffic comes in without authentication, in other words, it's HTTP or no auth, then it's bypassing IAM. And so that traffic will go through to the next layer of security. This is what we have launched, and it is security powered by our Open Distro for Elasticsearch open source project. So we have built a security plugin for Open Distro for Elasticsearch, and that plugin then uses an internal user database that allows you to specify the roles, permissions, and access for that occur within the cluster itself. Now, there's an important, again, if traffic comes in that's authenticated via Cognito or via IAM, where you have a user or role, that is termed a backend role within the security plugin. And we'll see where you set that backend role to say that that role should be mapped onto a particular internal role. We also have, again, our internal user database. If you come through with HTTP auth only, then you'll be authenticated within the security plugin against the internal user database. If all goes well, the request will be authenticated, and provided that it's set up that way, access will be granted to perform the actions that are present in the request. I wanted to call out a couple of the different common patterns in terms of doing authentication. So HTTP authentication is a really good place to start to get set up with the OpenDistro security. A request would come in with HTTP credentials. You can use a public endpoint with this method. Public endpoint is an endpoint that is exposed to the public internet. If you're doing dev and test, this can be a really convenient and easy way for you to set up an Amazon Elasticsearch Service domain and test it out. Best practice, as we'll see later, is to put your Amazon ES domain into a VPC. However, again, for dev and test, and you want to just make it a little bit easy, you can have a public endpoint with an open access pattern and then use HTTP auth within the Elasticsearch itself. So the request would come in, it will carry HTTP credentials, username, password. It will check, IAM will actually check that traffic. If the IAM policy allows for anonymous traffic, in other words, this is not authenticated to IAM, so as far as IAM is concerned, this traffic is anonymous. If you allow that, then the OpenDistro for Security plugin will check whether the credentials are valid. It will then check whether the action is allowed, and if all of that passes, then the request will succeed. If any one of those fails, then the request is denied. So as I mentioned, it's a best practice to use Amazon Elasticsearch Service within your VPC. When you do that, we always deploy the Elasticsearch cluster within a service-managed VPC. Now, to integrate with your VPC, we use Elastic Network interfaces that we launch into your VPC within a particular security group which you're going to specify. Okay, so provided that traffic can get in there, then it has to go through the security group, it'll hit the ENIs, and then that traffic will come and engage IAM and the security plugin as we discussed before to authenticate and do access control against it. Our general pattern to get traffic to Kibana from outside your VPC is to employ some kind of bastion or reverse proxy to use SSH tunneling to get traffic into your VPC from outside. Usually you're running on a laptop somewhere outside of AWS and you need to get that traffic in. So we use a bastion or proxy that has access to the ENIs which are within the security group, and then they would forward the traffic to there. And again, the whole security model would take place after that. For IAM authentication, so this is the alternative, one alternative to the HTTP basic auth. We're going to use AWS SigV4 signing, and we're going to put the credentials onto a request. So we have a request with IAM credentials coming in. The client is going to connect to the VPC. If that's allowed, then we have the security group, which is gating access below it. If that's allowed, then the IAM layer is going to go check credentials and access to the underlying Elasticsearch service domain. If that passes, then it'll go into the security plugin, and security will allow or deny the action. There's a single user that, when you use the fine-grained access control, that is the master user. This master user is created by the console or APIs, and it's special in the sense that the service is managing that user, right? So if something happens, somebody administering the clusters deletes that user, you can always come back to the console, or via API, you can always recreate that user. If you choose to use, so you can choose either HTTP auth or IAM as the source for the identity of that user. I recommend that you use HTTP auth. It makes things a lot easier. That means you can always set that up. For IAM users, you have to add the backend role into your domain to be able to do it. So that's a little bit harder to get set up and administer. And if you start with HTTP auth, at least you can add that backend role. All right, we're going to do a little bit of detail about IAM because, again, IAM is one of the core components of the overall security model. If we look at an IAM policy, and this is a policy that can exist either on the domain itself, or it can exist on the individual user or role that you're authenticating as. We have an effect. This is allow or deny. You can use a principal. This is an AWS account ID, or actually it's a user or role ARN. You set an action, which is either the HTTP verbs or service actions, then a resource, which is a particular domain and potentially a particular index. And then finally, optionally, you can specify an IP address or sitter block for which this policy should apply. So let's look at some examples. So when we were talking about the overall security flow, the first model was the HTTP auth model. So in this case, we're going to use an open policy that does not do any authentication or access control. It's simply going to use the open distro security based on the username password that comes with that HTTP request. We don't recommend this for public endpoints. Again, best practice is to have a VPC endpoint. If you have a public endpoint, you should probably use a policy and a means of authentication that gets that traffic into the domain authenticated. However, this is a strictly open policy. So in this case, we're allowing AWS star, everybody, to do ES star. So that's any action from any user on a particular domain. That's the domain ARN, that's the resource. If we want to set up a policy for VPC access, and if we think about the model that I presented where you're using a bastion or other EC2 instance or proxy that's at a known IP address, then we can at least add some filtering in for that IP address or sitter block that at least closes down access a little bit. So if I'm doing VPC access, then I can use a sitter block, and in that case, I have AWS star, so that's any request. ES star can do anything, although best practice, you lock that down. Particular domain is the resource, and then I add a condition that the source IP is a particular IP, and in this case, it's sitter block. I just wanted to quick detour and say, in terms of security groups, when you set up your security group, minimally you want to allow access via port 443. So we're launching in a VPC, we have those ENIs within a security group. That security group should allow 443. It could, depending, allow other traffic. When I do this for kind of dev and test and demo, I usually put the bastion in the same security group, in which case I need to have SSH access there as well. And again, you can enable port 80. Obviously, port 80 would not be TLS, and 443 is TLS. It gets a little bit more complicated when you use Cognito. So if we think back, we have integration from Kibana and sign-on via Cognito. I won't go into the whole details about Cognito, but suffice to say that you set up identities in Cognito, and then you will authenticate against that user pool. That traffic then will come, and you can either use a default authenticated role, or if you want to, you can be more granular and specify individual roles for individual Cognito users. If we look at the IAM setup for that, then what we want to do is allow a particular principal, and this one, the ARN AWS IAM blah, 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 Cognito identity pool auth role, you'll replace identity pool here with the name of your Cognito identity pool, but the rest of it is fixed. This will be the default role that users who authenticate through Cognito will get when the traffic arrives to Amazon Elasticsearch Service. So this policy lets that particular authenticated entity perform the HTTP actions against the domain. We'll get into that in a second. So what are the actions that you can enable or deny at the IAM level? There are admin actions and there are REST actions. So the admin actions are things like creating, deleting domains, updating domains, listing your domain names. Those are the administrative commands. Then below that, we have the REST actions that you can perform. Elasticsearch, again, REST-based. So I use things like ES-HTTP GET or ES-HTTP PUT to allow traffic to either read or write to the domain. And again, we specify the resource here. So for this first demo, we're going to deploy a new Amazon Elasticsearch Service domain, and I want to focus in the console just to look through some of the options that I'm going to use when I create that domain. All right, so we've logged into the console. I'm going to navigate over to my Elasticsearch service. And I'm going to select create a new domain. So the first thing that we have is a choice between production, development and test, custom, and ultra warm preview. We're going to choose the custom. You can choose the dev and test or production. That'll set some of the parameters in subsequent screens, but it's easiest to see everything by choosing custom. We're going to choose the latest version of Elasticsearch that's supported in the service. This is Elasticsearch 7.1. First thing we need to do is provide a name for the domain. We're going to call this Fine-Grained Access Control Demo 2. I get to choose the data nodes. I'm going to first pick my availability zones. I'm going to select a 2AZ deployment. We support a number of instances within the service. As you can see, the I instances, the C instances, the R instances, the M instances. I'm going to stick with the default R5 large. And when we have two availability zones, we have to have an even number of instances. So those are the data nodes in my cluster. I have a choice to pick storage. The best practice and general recommendation is to use the GP2, the general purpose SSD volumes. 10 gigabytes is going to be plenty for my demo. I get to deploy dedicated master nodes. For production, we always recommend that you do deploy dedicated master nodes. In this case, because it's a demo, I'm not going to deploy dedicated master nodes. All right, so now we've come to the Access and Security tab. And so here we can see all of the options that I talked about laid out. First of those is VPC access. And again, this is the recommended way to deploy. We can choose public access. If we have a public access domain, then the domain will be published as a DNS entry to the whole internet. Obviously, it's more secure to use VPC. I'm going to select as a VPC. I have one here. Within that VPC, then I'm going to select the subnets where I'm going to have my Elastic Network interfaces. In this case, I'm going to use this public subnet 0 and public subnet 1. Those are public in virtue of having a NAT gateway that's going to allow traffic to flow to them and an internet gateway that's going to allow traffic to flow out of them. I'm going to use the security group that I've already defined. You saw the settings for that on the prior slide. And I've now set up to launch within this particular VPC, within those two subnets, and with the security group I've defined. Fine-grained access control, again, this is our newly launched feature. I am going to enable fine-grained access control. This is where we set our master user. Again, the IAM ARN is a somewhat more complicated way to do this. So I do recommend using a master user that you create with basic HTTP authentication. For username here, I'm going to make it simple. I'm going to call it John. I'm going to use a very secure password. And that is going to be set up as the initial user for that domain. Then I'm not going to enable Amazon Cognito authentication. I plan to use the proxy and SSH tunnel method of connecting to my domain, so I don't need to authenticate via Cognito to have signed traffic that's authenticated by the IAM layer. For my access policy, again, for dev and test, it's fine to select an open access. And in fact, if you've launched into your VPC, then you're going to already have traffic restricted based on that traffic is already inside the VPC. So it's a little bit more acceptable in a security setting to say, okay, well, we're not going to do IAM access control at the edge of the domain. We're going to use the fine-grained access control inside the domain to allow access. Here are our encryption settings. Because we've selected fine-grained access control, we require HTTPS traffic. We have node-to-node encryption enabled and encryption of data at rest. As you can see, I can pick a KMS master key of my own, or I can use this default AWS key. So that's it. That's our settings. We have a review page. You can see data nodes, snapshots, Elasticsearch network, all of this. Here's the access policy, by the way. You can see here, again, it's this principal AWS star action ES star. So essentially, this is a full open access. I'm going to confirm that, and that is going to go create the domain. So while that is happening, I'm going to come back to my presentation, and we're going to talk about sort of at a deeper level, what can the user do, and I'm going to show you the demo that I'm going to run, how I'm going to set it up. So we have role-based access control. We're going to create roles that have different permissions assigned to them, and then create users and map them onto those roles. I have a fine-grained level of access control that we're going to get into where I can do document or field level security. I can add exclusion or inclusion for particular fields, and I can anonymize data on the way out. And then the last thing we're going to look at is Kibana, where we support a multi-tenant Kibana pattern that allows different users to have their own private set of visualizations and dashboards. This means that if you've deployed Elasticsearch clusters that handle many groups within your organization, you can segregate visualizations and dashboards along with the ability to segregate access to the underlying data. So let's look at the demo. We're going to use the Kibana sample data. This ships with Kibana, and it provides us 3 different indexes. So we have some e-commerce data, we have some log data, and we have some data about flights. We're going to create 2 users. One of them will be an e-com user. The other will be a flights user. The e-com user will be able to look at the e-commerce index. The flights user will be able to look at the flights index. And actually, they'll both be able to look at the log data. So let's log in, and we will create those users. Now, in order to do that, as I said, we're using the proxy and SSH tunnel, the Bastion and SSH tunnel method. So in this case, I have my proxy set up as an EC2 instance at that IP address. And I'm just going to map my local port 8123, all of the traffic onto that proxy. And that proxy, by the way, is in the same security group as the endpoints that I've launched in. I'm now going to run Chrome. In order to run Chrome with a SOX proxy, I need to actually run it from the command line. So this is the command I'm going to use, and that is going to set up Chrome. So here we are in Chrome, and I'm going to put in the endpoint for my domain. This is a different one I had prepared before. This is our OpenDistro for Elasticsearch security plugin presenting us a login screen. The traffic has come from my laptop. It's gone through the proxy server via SSH tunnel that I have set up within the VPC within the same security group. I'm going to log in. And we've come to Kibana. So the first thing we're going to do is we're actually going to load the sample data, since we have this nice splash screen here to do it. We're going to add the e-commerce data, flight data, and web logs. That just takes a second. Then let's go, and over here you can see the normal panes or the normal tools that Kibana provides, along with our OpenDistro security plugin and our tenants for Kibana, our multi-tenant experience in Kibana. I can log out up here on the top right. So let's go ahead and set up the users. So we'll click on the security tab, and you can see here are the options that I have within the security plugin. I have my internal user database, I have my role mappings and roles, my action groups, and my tenants. So let's go to the internal user database, and you can see here, this is the master user that I set up in the Amazon Elasticsearch Service console that's been created for me within Kibana and within Elasticsearch. It's locked because, again, this is something that is service managed. But we want to create our ecom user and our flights user. So let's add a new internal user, and we're going to call it ecom user, and the password here. We could add a backend role for this user, but we're not going to do that during this demo. So that's all I need to do to create a user is put in the username and password. Okay, so we've now created our ecom user. The second user we want to create is our flights user. So let's add one more user. We'll call it flights user. Alrighty. So we now have created two users. Let's pop back over to our presentation for a moment. What we now want to do is create roles that will provide the access patterns for the different indexes. And we're going to create a role for each of our different indexes. That will specify the ecom role will allow me access to the e-commerce data, the flights role to the flights data, the logs role to the logs data. So let's come back to our security and let's create a role. So let us add a new role, and I'm going to name this one ecom role. And you can see I have a set of cluster permissions, index permissions, and tenant permissions that I can apply to this role. In this case, the cluster permissions are based on, again, action groups, which are groups of permissions, right? So this is where I would add cluster actions, things like composite operations, read-only operations, monitoring, etc. In fact, we don't really need any cluster level roles. We want this user simply to be able to access the data in that index. So we're going to go to index level permissions, and we're going to add. Now we get to specify an index pattern. This is the set of indexes for which this role will have these permissions, right? In this case, because we are doing data e-commerce, did I do that right? Yep. Kibana sample data e-commerce is a name. We can use a wildcard here, but wildcarding can get a little bit tricky. For log analytics use cases, you are going to use a wildcard. What you do want to have is a unique prefix that you can make sure that you're not making the permissions overly wide because your wildcard is matching too many indices. For the action groups, again, we have examples here that are things like CRUD, data access, delete, get, index. We're going to give this user, this role, the permissions to do all operations on this index. That's indices all. This is our document level. I'm not going to put any document level security in for the demo. Here you would define a query that essentially would filter, and it could be an arbitrary query that's applied to any documents that match user queries or requests that come in for this index. And below it, we can include or exclude particular fields for this role. We can also anonymize fields on the way out. So that is our index permissions for this particular user. I'm going to save that one. And I'm going to create the flights and logs user. Sorry, roles. And I'm going to do this quickly without talking. Okay, that's my flights role. And I'm going to add my logs role. Okay, so I now have created the ecom role, the flights role, and the logs role. Let's come back to our presentation. So our picture looks like this right now. Nobody is hooked up to anything, but they exist. So let's go over back to Kibana and get that set up. So now we have the roles existing, we have the users existing. We're going to map the roles onto the users. So these are the role mappings I have. John has all access and John has security manager. I'm going to add a new mapping here. I'm going to add a user. This user is going to be the ecom user. Here's where I would bring in the Cognito backend role. If I authenticated with Cognito, I would get an IAM role here, and then I would add it as a backend role. Okay, so the role I'm mapping onto is the ecom role. The user I'm mapping onto is the ecom user, and I'm going to submit that. I'm going to do the same for the flights user, flights role, and flights user. And I'm going to create a mapping for the logs role that includes both the ecom and flights user. All right, so we now have our access set up like this. So let's go ahead and test that out. Currently logged in as John. I can go over to my developer tools pane here and I can quick get to work. And if I do, let's just look at the indices that we have. So we have here, you'll see a .kibana1 index. That's our way of segregating out different users. So this particular .kibana index is the one that I'm actually generating through using Kibana right now. We have the Kibana sample data logs, Kibana sample data flights, Kibana sample data e-commerce, and in fact, my user John can access any of those. So if I do get Kibana sample data, say flights /search, you'll see I get a response for that. As I will if I search that was flights, let's do ecom. And you can see again, I get results here. Okay, so let me log out. And let's become the ecom user. And I'm going to log in. All right, I did a bad mistake that we're going to have to fix. Let's explore on my own. Let's see if this is going to work. Okay, so I have search results for e-commerce data. Now, I should have no search results for the flights data because I did not give the ecom user access to the flights data. And as you can see, I get a security exception, no permissions to read or search for ecom user against this index. However, I did also get access to the logs index to allow me to get search results from there. So we have this picture set up. Now the next thing we want to do is look at Kibana multi-tenancy. The idea here is I have some set of indexes that are generated by Group A and some set of indexes generated by Group B. Group A wants to create dashboards and visualizations across that data. Group B also would like to create dashboards and visualizations against their data. But Group A should not be able to see the visualizations and dashboards that Group A has created and vice versa. When you use Kibana in Amazon Elasticsearch Service, you're able to select a tenant. So a Kibana tenant is a particular set of, basically it's a .kibana index that holds a set of visualizations, dashboards, etc. You assign tenants to users via roles to allow them access to that particular tenant's set of visualizations and dashboards. But a very key point here is that tenancy is not the same as access control. So your tenant, you may try to give your tenant access to a particular index via the index pattern that you're going to create in a second. But if the tenant doesn't have access to that index, then that's not going to work. So you have to make sure that your tenancy, you keep that separate in your mind from the access control for the particular indexes that that tenant is accessing. So let's come back here. I did make one critical mistake that I have to fix. And that is that we have a special role, which is called the Kibana user role. Any user of Kibana needs to have this role in order to do the normal operations that Kibana is going to do, like create an index pattern. So let's go ahead and map that onto our users. So let's take the Kibana user role and let's add the ecom user and let's add the flights user. And we can also add the logs user. Okay, so now our user should be set up to do the creation of indices and other things that Kibana needs to do. Okay, now that we have our Kibana user mapped onto our ecom users, let's go ahead and look at the tenants that we have available. Initially, we have only a global tenant. And let's also add a logs tenant. Oops, not description. So this is going to apply, I can select this, and if I do my work against the logs index, all of that work will fall within this tenant. Let's also create an ecom tenant, and let's create a flights tenant. All right, our tenants are created. Now, the way that I apply a tenant is via a role. So if I look at the ecom role, I can set it up so that it has access to particular tenants. So let us add tenant permissions, and let's add a tenant pattern that is the ecom tenant. And let's also add the logs tenant. So we have a shared logs environment as well as a particular environment for this role. And let's add fields. Let's do Kibana all read, and we'll add Kibana all write. Okay. So we're going to save this as the role definition. I'm just going to set up that particular tenant access, and we're going to demo that. So let's log out, and we'll log in as the ecom user, and we'll see how the tenancy works. So when I'm using Kibana within Amazon Elasticsearch Service, I have this icon over here that allows me to manage my tenant. I select that, and you'll see here, because of my role, I have access to the ecom tenant and the logs tenant as we set it up. There's also a global tenant. I can do work within the global tenant, and then everybody has access to the global tenant. There's also a private tenant that is my own tenant itself. This is selected by default. Let's go ahead and do one visualization in the ecom tenant. So I selected the ecom tenant, I'm changed that. Now everything that I build in Kibana visualizations dashboards will go under that tenant. I'm going to go quick build a visualization, and I need to create an index pattern. Here's again where you need to be very careful. If I just put, let's say I just put Kibana star, right? That is going to try to access all of the Kibana sample data indices. Some of them I don't have access to. Downstream, that's going to cause problems because I'm going to be trying to access indices that I don't have access to. So let's use here, we'll be very specific, data e-commerce. And let's go and create that. I'm going to use, e-commerce data doesn't have a time filter. All right, let's create this index pattern. So we have our normal index pattern. We're going to go over and create a visualization. Actually, first let's go to the Discover pane. We'll see where this data lives. Actually, it doesn't live on a timeline, so we just have data. Let's do a quick bar chart. We're going to create a visualization, and we are going to do a, let's do a vertical bar. Where did you go? Oh, it's under V. And I'm going to use my index pattern for the e-commerce data. And let us split the x-axis based on the categories. So this gives us the different categories that we have within our data. Simple visualization, let's save that. And we'll save it as categories. I could build this into a dashboard, but I think for the purpose of the demo, we'll just show that the flights user does not have access to that tenant and hence does not have access to the visualization I just built. And we need to first set up our flights user with their tenant. So let's quick go over here. We'll manage our roles. And for our flights role, we're going to add tenant permissions for tenant permissions. So let us add a tenant pattern here. So we're not going to do the ecom tenant. We're going to do the flights tenant, and we're going to add the logs tenant. All right. So now our flights user has access to whatever's in the flights tenant and whatever's in the logs tenant. So if we log out and log in again as the flights user, and I have my I can remember my password. Okay, so I'm now the flights user, and I'm going to go and look at my tenants that I have access to. I have my flights tenant and my logs tenant and my private tenant. So if I go and try to open a dashboard, you'll see that I don't have any index patterns and no access to any of the visualizations. I can try to create a dashboard, but I still need an index pattern. All right, let's use the Kibana sample data flights. This one does have a timestamp. I can create that. And again, what you'll see here is I don't have access to the visualizations that I created with my ecom tenant. So if I'm creating my dashboard and I try to add some existing visualizations, I don't have anything there. So what we've done is we've set up, first of all, so that we have different users having differential access to the indices, which we created via roles. And those roles had permissions that gave us index level access, is what we set up, though we could have done document or field level access. And we set up a multi-tenant environment where the ecom user created a dashboard. The flights user did not have access to that dashboard because it couldn't change to that particular tenant. So overall, again, this is the picture that we created. And we did our demo. I wanted to mention, we do have API-based access, so you may have been concerned as I was talking that you would have to go through the UI to do all of this setup and work. In fact, all of the UI, all of those commands have API counterparts. Those come at your endpoint via the _OpenDistro_security API calls. This particular one is an example of a role mapping. So we're mapping WRF onto a bunch of backend roles. You can see the docs. We have it all documented out. So all of this can be stored as text in a source control system. You can have your whole setup that you can use APIs to support creating all of the users' roles and permissions. So Amazon Elasticsearch Service has brought all of this out as of this week, and we are deepening our security model and powered by OpenDistro for Elasticsearch's security plugin. We have a multi-layer model where you can use IAM to authenticate individual traffic at the edge. You can use Cognito for Kibana sign-on, or you can use federated IDPs integrated with Cognito. We provide role-based, fine-grained access control, index document field level, and we provide a multi-tenant Kibana environment to segregate data visualizations and dashboards. Thank you very much for your time and attention. I really appreciate it.